is 6.3a. It's called add or subtract radicals. And they're very similar to like how when we added and subtracted variables. Just like 3x plus 5x, they're like terms. So we add the coefficients, which get 8x. That's the same with radicals. For them to be considered like terms, though, they have to have the same root and the same radicand. If like terms, if you have like terms, then you can do like we did up here. You can add or subtract. The coefficient, and then you tag on the like term part of it. Okay, so for instance, if you have 3 square root of 2 plus 5 square root of 2 would equal, since you have right here, we have the same root and we have the same radicand, then we could take the coefficient that's in front and add them. And we get 8 square root of 2. Let's do this one. We have the square root of 36x minus 8 square root of 5. So, like we were doing before, you want to simplify each expression. So we know that 36 times 6 is 36. So because it's square root, we need 2. 6 comes out, we get 6, and the x stays in. However, on this one, we have 8, the square root of 5. 5 only has 5 and 1. That's it. So are these like terms? They do have the same root, but they don't have the same radicand. So you cannot add these two together. They are not like terms. That is your answer. Now let's try 5 square root of 180 minus square root of 20 minus square root of 45. So let's work these out. If we want to know what, we have the index of 2 or the root of 2, so we need pairs. So 5 comes out of that, gives us 36. Then we have, we know that 6 times 6 is 36. And since we're looking for pairs, we have a 6. And there's a 5 that's left in. Now let's do 20. We know that 5 goes into that 4 times, and then 2 times 2. So 2 comes out because we have a pair of 2's. So square root of 5, and we know we're subtracting that one. Then we have 45. 5 comes out of that, and it is 9. 3 times 3 is 9, so we have a pair of 3's. So subtract 3, square root of 5. Now we're looking at our radicands, which they're all the same, and our index or our root is the same. It's a 2 for each one. So those are like terms, so we can add our coefficients. We have 6 minus 2 minus 3, which gives us 1. Maybe. I think I did something wrong. Oh, yes I did. I forgot to add this one in. I pulled out a 6, but I forgot to multiply it by the 5 that was already there. So that changes our answer. we have 5 times is 30. So if 30 minus 2 minus 3, which, well, that's 30 minus 5, which gives us 25. Square root of 5 would be our answer for that one. These just act like labels or tags when you're adding and subtracting, just like our variables do, our x's and our y's. If they're the same, they just go along for the ride. Now let's see if we can do another one without me goofing up. We have a -7 square root of 45 plus 3 square root of 5. We already know the 5 is as simple as it's going to get. So we had, earlier we did this, we took 5 out, had a 9, which is 3 times 3. So we got a pair of 3's, so we have -7 times 3 square root of 5 here. And we can't do anything here because we can't pull anything out. It's as simple as it's going to get. So we have -7 times 3 is -21 square root of 5 plus 3 square root of 5. Check to make sure we have like terms. I don't know if this will show up or not. We have the same radicand, we have the same root, so those are like terms. So we just add our coefficients together. We have a -21 and a 3, which give us -18 square root of 5. Our like term just goes along for the ride. That's our answer for this one. Now let's try another one. We have -7 square root of 25y minus 6 square root of y plus 8 cube root of y. Okay, well, let's look at each individual term. This one here, we have, it breaks down to 5 times 5, and it's a pair, so we can bring it out. So we have -7 times 5, but we only have one y inside, so the y has to stay. So this is -35 square root of y. And we can't take anything out of this one because we just have one. So we can just bring it down. And again here on this one, we have one y inside, but we need 3 to take it out, so it can't come out. So it just kind of comes down. Now we're looking for like terms. We have square root of y, and we have the cubed root of y. These two are the same, but this one is not. So we can add these two together, but we can't, this one is not the same, so we can't add it. So -35 minus 6 is -41, and our y squared tags along, and then we have 8 cube root of y. Since they're not the same, you can't add them together, and that's as far as we can go. Let's try this one. The square root of 64 x cubed y to the 7th, all of that's inside, minus 4x cubed y to the 7th minus 81x cubed y to the 7th. Interestingly, if you notice, all our variables on each one are the same. So let's go ahead and let's find out what x cubed y to the 7th, if we take the square root of that, is. So we're going to divide 3 by 2, so we can pull 1 out, and 1 stays in. 7 divided by 2 is 3, so we have 3 y's that come out, and 7 minus 6 is 1, so 1 stays in. So this is our tag that goes on the end of all of these. So let's go back to our original problem and let's finish it. So the square root of 64 is 8, so we have 8xy cubed square root of xy Then we have 4. The square root of 4 is 2. So we're going to put this tag along the end of it. And then the square root of 81 is 9. Then we have x, y cubed. Square root of xy. Still, we have the same tag, so all we're really doing is looking at our coefficients. Since all of our tags are the same, 8 minus 2 is 6, minus 9 is -3. So our answer for this one is -3xy cubed, and square root of y, xy. Kind of a lengthy process, but that's how we get to it. You just have to make sure that follow through and be very careful with what you're doing and making sure that you're not dropping anything along the way. Let's do another long one like that one. We have square root of 81, a to the 17, b to the 25, minus 16, a to the 17, b to the 25, plus 25, a to the 17, b to the 25. Okay. If we look at our variables in each one, they're exactly the same. So we can go over here and we can figure out what a to the 17, b to the 25 is when we take the square root of it. So if you take 17 and you divide it by 2, you get, I believe it's 9, no, 8, because 9 is too much, 9 is 18. 8 times 2 is 16, with the remainder of 1. Then we have 25 divided by 2, which is 24, with the remainder of 1. So we have, outside we have 8 A's, 12 B's, and inside though we have 1 A and 1 B. So that's what our tag is going to be like for each one of those. So what is the square root of 81? It's 9 with our tag. Square root of 16 is 4, and then we're going to put our tag with it as well. And the square root of 25 is 5. Okay, since our tags are all the same, we only have to worry about our coefficients. So 9 minus 4 is 5, plus 5 is 10. So 10 plus our tag, or our label, and that's our answer. However, sometimes that's not going to be the case. We're not always going to have the same tag on each one, so be careful. Let's try this one. 6 square root of 20 minus 6 square root of 25x. Well, we're going to do the factorization of 20 to find out how many pairs we have. We've got 10, 2, and 5. So we got a pair of 2's that come, 1, 2 comes out. So 6 times 2, and 5's left inside. And we know 5 times 5 is 25. So we bring a 5 out, that multiplies the 6, and then the x stays inside. So we have 6 times 2 is 12, square root of 5, minus 30, because 6 times 5 is 30, square root of x. We check our labels or our tags here. We've got the radicand of 5, radicand of x. We can stop there because they're not the same. We cannot combine those two terms. That is our answer. Now we have let's try this one. It's not as complicated, but sometimes the easy ones can get us just as easy as the hard ones. Okay, we want to find out how many, because the index is 2 on each one of these. We have the square root. We want to find how many pairs do we have in 75. So 5 goes into 75 5 times, or 15 times, and then 5 goes into 15 3 times. So we have a pair of 5s. So we have negative, because it's -1 times 5 is a -5, and then what's left inside is a 3. Now let's do the 27. We know 3 comes out, or 3 times 9 is 27. 3 times 3. Here's our pair, because we're looking for pairs, or our index is 2. So we have 8 times 3, and then square root of 3 inside. And then plus 5 square root of 3. Now, if we combine, that's, what is that, -24? Plus 5 square root of 3. Our radicands inside are the same. Our indexes are the same. So these are like terms. So interestingly though, this 5 is negative and this 5 is positive, which causes us to cancel. So our answer is -24 to the square root of 3. Okay, let's do one more. And this one is we've got the cube root of 27x 22y 16. And we have the cube root of 64x 22y 16 plus x, we want the cube root of this one as well, y 72. No, that's 14. Alright, if you look, these two have the same variables, but this one doesn't. So let's go ahead and find out. We know that cube root of 7, or 27, is 3. But we want to know what the cube root of x 22, y 16, and we want the cube root of that. So 22 divided by 3 is 21. 3 times 21. Remainder of 1. Then we have 16 with 3. 5 times 3 is 15 with the remainder of 1 here. So we know we have 7 x's will come out and 5 y's will come out. But inside our cube root we have 1 y and 1 x is left because of our remainders. And this, since it has the same exponents for this one, we're going to have the same tag as right here. But the cube root of 64 is 4. So it's 4x to the 7th, y to the 5th, and in the cube root of xy. And let's see, what do we get when we take this one and take the cube root of that? So 8 divided by 3 is 2 with the remainder of 2, and then 14 divided by 3, 4 times 3 is 12, remainder of 2. So we don't have any numbers here, so it just pulls out. We're adding 2 x's, 4 y's on the outside, and inside our cube root we have a remainder of 2 for each one. So as you can clearly see, what's inside our radicands are different. Even though our exponent's the same, all of this has to be the same. From here, all the variables outside and inside have to be the same in order to add them. These two are the same, so we can add those two coefficients. That gives us, what, 4 plus 3 is 7. But since these are different on the outside, we can't add them to this. It has to remain by itself. And that is our answer. Kind of got a lot there. All right.